In this lesson, we're going to talk about iterators and dictionaries. Let's start out first by creating a new program. We'll call it dictionator.py. And let's create a very simple dictionary. Let's just call it grades. And we'll set a couple of names and grades just to have something to work with. And that's good enough. Normally, when we write a loop through a dictionary, we use the following pattern. We pull out each key out of the keys function and print the key and then the value associated with the key by indexing into the dictionary, like so. So let's run this real quick. So there are 3 names and grades. And you might think it's kind of hard for a dictionary to have an iterator since we have a more complex data type, since we have a dictionary with key value pairs. And it's true that we can't have an iterator return both the key and the value, but we can have an iterator into the keys. So let me demonstrate how that works. So we'll create an iterator. We can create an iterator into the dictionary by calling the iter function with our dictionary as the argument and assign it to a variable. In this case, we'll use it. Then we can write print next it, and let's see what that gives us. So it gives us the first key, Clayton. So if we do it again, it should give us the second key, or the next key. Remember, dictionaries, you don't really talk about order in terms of first and second. All right, so there are our first 2 keys, and if we ran it again, we get the third key, and we don't need to do that. So what that means, having an iterator into the keys, is that we can write a for loop where we just access each key in the dictionary, and we can then access all the values. So let's run this again. So there you see we have the same result as we got in this loop using a less complex statement, which means, of course, that your program is easier to read and that it's probably going to be more efficient. So that's how iterators work with dictionaries. And now we're ready to move to the last lesson in this chapter, where we're going to look at just a miscellaneous group of other iterators that are available in Python. For this last lesson of the chapter, we're going to look at how to create iterators for other sequence types in Python. So we're going to start this program. We're going to call it Iterators.py. So the first thing we're going to do is we're going to build a range. So we'll write numbers equals range 1 to 10, which means we have to go 1 to 11. Not that we're going to iterate over that whole range, but just demonstrate how to create an iterator for a range. And to be quite honest, it's no different than we've done for any other type of object. So if I want to create the iterator, I'll write it equals iter numbers. And now if I want to see the first number in the range, I just type print next it. Let's save the file. Then we'll run it. And my first number in the range is 1, and we can continue on just like we would with any other sequence type. So ranges work exactly like a list or a dictionary, for example. Let's look at one more example. In Python, we have the ability to import libraries that allow us additional functionality than what is found with just the regular built-in Python functions, for example. One of the commands I want to work with will return a sequence of data, and it's called popen. And what it does is it allows you to run a operating system command, like a directory, and then it will return that data into an object, and that object is iterable. So what I'd like to do is we're going to first import the library, import OS, that gives us access to popen. Then I want to say files is equal to os.popen, and then we provide the command that we want to run. In this case, I want to do a directory of all the Python programs in the current working directory. So I'm going to type dir star.py, and that will return all files that have a py extension. So then once I do that, I can create an iterator on that object just like so, and then I can display the objects in that sequence. Now the problem is that there's going to be a lot of blank lines, because if you'll notice what happens when we get a directory, let me run that for you real quick. If I scroll back up to the top, you'll see that there's a couple of lines of just basic information about the hard drive, and then we have a little heading for the directory of C:\Python 3.0, and then the files. So I probably want to display 1, 2, 3, 4, 5, 6, or 7 lines just to get the first files to appear. Let's go back to the code. Let's copy this. Then let's paste it in a few times. We'll say 6 or 7 times. And I could have a loop to do this. If I was going to do it in a loop, I might as well do it in a for loop, which I could very easily do. In fact, let's look at that first. I'll tell you what, let's do. Let's erase this. We'll come back to it. Now let's run this code. Clear the screen. There are my files. And so what I did was I ran a system command and then used a for loop to display the data. So now let's do it with an explicit iterator instead. We'll put those back in, and that's not going to show the whole directory. Let's clear the screen. And so there we get our first view. And notice it is printing a blank line, so we could fix that by adding end equals empty string to our display. But I'm not going to add that to all of these lines. So here we've seen 2 other sequences of data that are iterable. In other words, we can create an explicit iterator and traverse through the sequence using that iterator. And with that, we're ready to move on to the exercise for this chapter, where I'm going to demonstrate how to use iterators with yet one more data structure, and that's the tuple. In this exercise, we're going to demonstrate one more use of iterators, this time with the tuple data structure. So let's get started. First thing we're going to do is open our file. We'll call it chap9ex1.py. And what we want to do is we want to create a tuple that's a little more complex than just a standard tuple of single elements. So what we're going to do is we're going to define a square by its points. So I'm going to write out 4 points, or XY coordinates. So what we have is actually 4 tuples inside an enclosing tuple that represents the square, at least in terms of the points of a square. So here's my tuple, and as you can see, each point is represented as another tuple. So we have the point 10,8, the point 10,23, the point 25,23, and the point 25,8. That represents my square. So if I wanted to display the points of the square, I could write a for loop to do so. So let's save and execute the program. Oops, a little mistake here. Let's fix it. Right there. Try it again. So there are 4 points. To capture that same output using an iterator, we'll go back to our code, comment out the for loop, create an iterator object. We'll call it square it, or square it, and we call the iter function with our tuple. Then to print the 4 points, we're simply going to call the next function on square it and do that 4 times. So what I'm going to do is I'm going to type it out one more time, then I'll copy and paste. Control C and then Control V. So that should give us our 4 points, and we don't want to go farther than that. There's nothing else in the tuple anyway. But if we did, then we would get the stop iteration exception. I brought that up just to remind you that in our chapter on exception handling, I'll demonstrate how to use a while loop to go through an explicit iterator and not have the stop iteration exception thrown. But anyway, so now we're ready to display our 4 points. So we're going to click File Save, clear the screen, and there are 4 points again. This exercise demonstrates that we can use iterators even with complex data structures where we have tuples stored inside of tuples. And with that, we wrap up this chapter on iterators.